Hello everyone. So today we are going to discuss one Hoff factor and it is represented by I. This is the last part of the lesson solution. It is part 12 and today the solution lesson will be finished. So one Hoff factor. What is one Hoff factor? How it originates? Let us discuss it. So myself Muhammad Ruhul and we are watching our channel Ruhul's Tutorial. Now suppose we have taken one solution. Suppose one question is there. What is the del Tf? We have to find depression in freezing point. Del Tf for 1 molar solution of 1 molar solution of KCl in water, and water, the Kf for water is 1.86 Kelvin kg per mole. It is given. One question is this one. What is del Tf for 1 molar solution of KCl in water? If it is given that Kf for water is 1.86 Kelvin kg per mole. Second question is that what will be del Tf, okay, for 1 molar solution of glucose in water, and here also given Kf is equal to 1.86 Kelvin kg per mole. Okay. Third question is that what is del Tf for 1 molar solution of acetic acid, that is also known as ethanoic acid, acetic acid or ethanoic acid in benzene, and here given Kf for benzene is 4.9, Kf for benzene it is given 4.9 Kelvin kg per mole, and this is Kf for water, Kf for water. So 3 questions I have taken to clearly understand what is the role of one Hoff factor I. Now see, del Tf we have to find. What is the formula of del Tf? Formula is del Tf, depression in freezing point, is Kf into molality. Kf into molality. We have discussed it earlier and we know it. What is the Kf? 1.86. What is molality? Molality is 1. So this is 1.86 Kelvin kg per mole. Okay. Now in second, what will be the answer? Same. Del Tf is equal to Kf into molality. Kf into molality. What is Kf? 1.86. What is molality? 1. So 1.86. Okay. So what will be the unit? Unit will be what? Elevation in depression in freezing point. That is nothing but a temperature to Kelvin. Now here, so del Tf equal to Kf into molality. What is Kf? Kf is given as 4.9. What is molality? 1. That is 4.9 Kelvin. So this we are found that del Tf. Now when it was examined experimentally, when experimentally seen, it is found that in first case the answer is, experimentally it is found the del Tf was found to be delta F was found to be 3.72 Kelvin, means double of this it was found, means this is wrong. This is wrong. Now in this case, experimentally it is found that del TF is equal to 1.86, means this is right. This is right. Here experimentally it was found that the answer for this question is del TF is 2.45 Kelvin. So this is also wrong. But in our earlier study, we have also explained del TF. One video is there. Already formula we have studied, many numericals we have done on the basis of this formula only. Molar means molality. So according to the formula, answer is this, answer is this, answer is this. But only one is correct. Why two are wrong? Now if we see carefully, the answer of here is nearly double. For this answer is nearly half. So why answer is doubled, why answer is half, that will be explained by One-Hoff factor I. For this purpose it is used. So why it is half or double, so let us discuss this one. So this is right, this one is wrong, that one is also wrong. So what will be the right answer, that we will discuss now. Okay. Now see, One-Hoff factor. So One-Hoff factor, what is its definition? So first let us take definition, then we will discuss. One-Hoff factor, One-Hoff factor. It is denoted by I, and it is defined as the ratio. It is defined as the ratio. Whose ratio? Normal molar mass divided by abnormal molar mass. Abnormal molar mass. Normal molar mass by abnormal. Okay, abnormal molar mass means molar mass which is different. What we expect and what result come. What we expect and what result come, if both are different, then it will be abnormal molar mass. Okay. Normal means normal, whatever molecular mass value should be, and that is if present, that will be normal. And abnormal molar mass means what we are expecting, but the result is different. Okay. It is also called observed colligative property. Observed colligative property by calculated colligative property. Colligative property. Now, so this part will be explained later in this video, but after some time this will be explained. What is wrong here, what is right here. Okay, this after sometimes we are coming to the main topic, then it will be clear. Also, you can define One-Hoff factor as One-Hoff factor is equal to I is equal to ratio of the total number of moles, total number of moles of particles after dissociation or association divided by number of moles of particles after association or dissociation. divided by number of moles of particles before dissociation or association. So I have the three definition. There are three definition for I. What are they? First one is normal molar mass by abnormal molar mass. So normal molar mass means normal. Abnormal, the molecular mass which is calculated from colligative property. If it is different, then it will be abnormal. Or observed colligative property by calculated. Calculated means from colligative property we will calculate. And I is also equal to total number of moles of particle after dissociation or association divided by total number of moles of particle before dissociation or association. Now let us calculate I for some particles. Okay. So this is the definition of I. Now, suppose question is find I. We have to find the value of I. Find I for the complete dissociation of complete dissociation of first given one KCl. What is the value of I for complete means 100% dissociation of KCl? Okay. Now see, if KCl we break, it will be break into K positive ion and Cl negative ion. What is the formula of I? Total number of moles of particle after dissociation by before dissociation. So cancel association from here. So value will be total number of moles of particle after. How many moles? 1 moles of K plus 1 moles of Cl negative means 1, 1, 2. And what is the moles of particle before? So before it is only one time. So 2 by 1. Answer will be 2. The value of I for KCl is how much? 2. Okay. Take another one. Suppose K2SO4, what will be the value of I? Now first break. So how we will break? K how many times? 2. Sulfate how many times? 1. So rule for breaking is K is 2 times. So it will be 2 times of K. 2 times of K. Charge will be second one. 2 times of K. Charge will be second one. Plus 1. Plus of SO4 how many times? SO4 1 time. So 1 times of SO4 charge will be first one 2 negative. This one. So 2K positive plus 1 sulfate negative. What is the value of I? Formula is this one. So number of moles of particle after dissociation. After dissociation, how many moles of particles are there? 2 plus 1, 3. And before only 1. So answer will be 3. Okay. Take another one example. Example number 3. Suppose K4 FeCN whole 6. What is the value of I? Say, just you break it. K how many times? 4 times. Then FeCN whole 6. So what is the rule of breaking? Suppose AXBY is a compound, and if we want to break it, so how can we break? A how many times? X times. So X times of A. What is the charge? Second one. Y. So it will be Y positive plus. B how many times? Y times. So Y times of B. what will be the charge? First one. What is first? X. So it will be X negative. So AX time is there. So X times of A, charge Y positive, plus BY times. So Y times of B, charge is X negative. In the same way, this whole complex is one time. Break it. Now, what will we get? K how many times? 4 times. So 4 times of K positive, plus this how many times? 1 time. So 1 times of this Fe Cn whole 6. Charge will be first one, 4 is there, so it will be 4 negative. What will be the value of I? After dissociation, how many moles are there? 4 plus 1, 5. And before dissociation, how many moles are there? Just 1. So 5 by 1, that is 5. So I think it will be clear how we can find the value of I for dissociation. Now see, in all cases the answer is more than 1. 2, 3, 5, maybe 4, anything may be there. Okay. Now second, we will find the value of I for association. Dissociation we know, to dissolve, to break into ions. Association means many moles are there, many particles are there, they will join together. They will join together. Okay. So first find the value of I for association. What will be the value of I for association? Okay. Value of I for association. Okay. Now first it is given, first one, find I for dimerization of A. Okay. Dimerization means what? Two atoms of A join together. Dimerization means A is there. Dimerization means it is combined to form a molecule A2 type. So 2 times of A join together to form one molecule of A2. This is dimerization. Means 2 combine to form single molecule. 2 atoms of A join together to give one molecule. What will be the value of I? Total number of moles of particle after association, because it is associative, join together by before association. What is the moles of particle after association? How many moles? 1 time. So it will be 1 by. Before association, how many moles are there? 2. So it is 2. The answer is half. Answer will be half. Okay. Now second, for trimerization of A means, trimerization of A means what? 3 atoms of A join together to give A3. Trimer form. 3 atoms of A join together. What will be the value of I? After 1 time is there, before 3 time. The answer will be 1 by 3. Okay. Tetramerization of A. Tetramerization of A. What will be the answer? Means 4 atoms of A join together to give a single molecule. 4 atoms of A. Suppose 4A join together to give A4, means tetramerization occurred. What will be the value of I? That is moles of particle after 1 by before 4. So I will be 1 by 4. So if association occur, the value will be either half, 1/3, 1/4, 1/5, means less than 1. The value will be less than 1 for association, and greater than 1 for dissociation. So if greater than 1 for dissociation, less than 1 for association, if neither association nor dissociation occur, if neither association nor dissociation occur, then the value will be 1. Okay. So finalize, we can write that the value of I will be greater than 1 for dissociation. If dissociation occurs, the value of I will be greater than 1. Value of I will be less than 1. So less than 1, this one. If association occurs, and the value of I will be equal to 1 if neither association nor dissociation occur. So if neither association nor dissociation occurs, So if neither association nor dissociation occur, then the value of I will be equal to 1. So this we have to remember. Okay. So now we have done association or dissociation. We have find the value of I for complete association or dissociation. Complete means 100% dissociation occur or 100% association occur. Now in case if dissociation or association is not 100%, if it is not 100%, then how can we find? Suppose one question is there. Okay. First formula, degree of dissociation, how much it is dissociated. If 100% complete, if written, then it will be 100%. So degree of dissociation formula is alpha is equal to I minus 1 by n minus 1. Alpha equal to I minus 1 by n minus 1. I we know one-to factor. What is n? N is the total number of ions produced. Total moles of ions. Total number of moles of ions. How many ions are produced? Why? Because dissociation is there. Ionic compound will dissociate to form ions. What is alpha? Alpha is the degree of dissociation. What is alpha? The degree of dissociation. Now, degree of association. What is the formula for this? Degree of association is also denoted by alpha. And the formula is alpha equal to I minus 1 divided by 1 by n minus 1. I minus 1 by 1 by n minus 1. What is alpha? Degree of association. What is I? One-to factor. What is n? N is the, if dimerization occur, then n will be 2. If trimerization occur, then n will be 3, and so. Tetramerization, n will be 4, and so. So this is the degree of association. So if 100% dissociate or not 100% dissociate, then we can find the value of I. Now take 1-2 example. Okay. So find I. We have to find I. First question is there. For 100% dissociation 100% dissociation of magnesium chloride, and second we have taken for 80% dissociation of this, or any number you can take. Okay. Now let us solve this. Now what is given? Magnesium chloride, MgCl2. If we break it, then what will be the product? Magnesium one time. So one time of magnesium. What is the charge? Second one, 2. So it will be 2 positive plus. Chlorine, how many times? 2 times. 2 times of chlorine. What will be the charge? First one, so minus 1. Okay. So first question we are taking ki it is 100% dissociated. So 100% means alpha will be 100%. Why? Alpha is the degree of dissociation. Alpha is the degree of dissociation, means 100% dissociated. So the value of alpha will be 100%. What is the value of N? Total number of ions, how many produce? 1 plus 2. 1 plus 2 means total 3 ions are produced, and we have to calculate I. Kitna hoga? Use the formula for degree of dissociation. What is alpha? Alpha is the degree of dissociation. Degree of dissociation. How much dissolve? How much a compound is converted into ions for ionic compound. Use the formula. What is formula for degree of dissociation? Alpha equal to I minus 1 by N minus 1. What is alpha? 100%. What is the value of 100%? If you remove percentage, divided by 100 will be there. If we remove percentage divided by 100, 100 by 100, 1. So alpha is 1. I we have to calculate minus 1. And how many ions are there? 3. So 3 minus 1. 3 minus 1, 2. Here 2 equal to I minus 1. What is I? I is 3. So if we find normally as we have calculated previously, so what will be the I? Total number of moles of particle after dissociation, 1 plus 2, 3 by before dissociation, 1. Directly you can find from there, or by formula you can find. So this formula is also verified that it is right. Give the same answer. Okay. Now, if it is 100% dissociated, then you can find directly or by formula. If not 100%, then how can we find? Then we have to apply this formula only. So let us discuss about 80% dissociation. Answer number 2 for 80% dissociation. So for 80%, alpha will be 80%. I we have to find, and number of ions will be 3, because for magnesium chloride it is asked 80% dissociation of magnesium chloride. If 100% dissociate, then value is 3. 80% dissociate, the value will be less than 3. Value will be less than 3. Okay. Now give the formula. Alpha is equal to I minus 1 by N minus 1. What is alpha? 80%. I minus 1 by N minus 1. What is N? N is 3. So 80% means 80 by 100. I minus 1 by 2. So this will be 0.8 into 2, 1.6. I minus 1. So what will be the I? I will be 2.6. The value is what? Less than 3. So 100% dissociate 3. Less than 100% dissociate. So less than 3. So in this way you can find whatever percentage dissociation is given. Okay. If it is given 80, we are using 80. If it is asked for 60, give 60 and then simplify. Okay. The same question let us discuss for association. Okay. Suppose we have to find I, question number 3, find I for 100% association, 100% association or dimerization, giving dimerization of A, dimerization of A. Okay. So dimerization means two atoms of A combine to give a molecule. So first normal formula. By normal formula we can find this is 1, this is 2. Because it is 100% dimerized, you can write 1 to factor I. What was the formula? Number of moles of particle after association, 1 divided by number of moles of particle before association. So before association is 2, so 1 by 0.5. Okay. Now using formula, so what was the formula? Alpha is equal to I minus 1 by n minus 1. This was the formula for degree of association. For dissociation it is n, for association it is 1 by n. Now put the values. What is alpha? How 100% associated? I minus 1 by n. What is n? If dimerization occur, then 2, trimerization 3, tetramerization 4, in this way. So dimerization, the n will be 2. So 100% means percentage if you remove by 100, I minus 1 by minus half. Half minus 1 is how much? Minus half. So it is 1. So minus half come here, that is I minus 1. So minus 1 come this side, so I equal to minus 1 goes plus 1. So 1 minus half, and what is 1 minus half? That is half. So the value of I is same whether you can calculate directly or whether by formula for 100% dimerization. If it is not 100% dimerization, then directly we can't determine. Then we have to apply the formula. So let us discuss one more question for this association part. So question we have taken, find I for suppose 70% association, 70% association of A, or dimerization of A. If 100% dimerization, the answer will be half. If 70% dimerization, then answer will not be half. So what will be the answer? Let us check. So here alpha is equal to I minus 1 by n minus 1. What is the value of alpha? Given 70%. I we have to calculate n. N will be 2. Why? Because it is dimerization. Minus 1. Now simplify. 70% means if you remove the percentage, divided by 100 will be there, equal to I minus 1. Half minus 1 is how much? Half. And minus half. Now 70 by 100 is how much? 0.7. And this will be I minus 1 by minus half. If you multiply minus half, this will be minus this half, then 0.35 will be there, I minus 1. So minus 1 come this side, so 1 minus 0.35, that is 0.65 will be the answer. So see the difference. If 100% association occur, value is half. If not 100% association, means dimerization, then value is more than half. Half means what? 0.5. 0.5. So now we have come to know about I. What is the definition for I? Normal molar mass by abnormal, observed colligative property by calculated colligative property, or number of moles of particle after dissociation or association by before dissociation or association. After that we have find the value of I for dissociation, for association. For dissociation greater than 1, for association less than 1. If neither association nor dissociation occur, then 1. And for 100% dissociation or association or less than 100%, two formula we have got. With the help of that formula we can easily find. Now let us take a starting part why the answer was not correct, and in the middle part it was correct. So for that, Hoff, the name of the scientist, Hoff modifies the equation of colligative property. Hoff modifies the equation of colligative property. So what was colligative property? We have already come to know. Relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. So these all colligative property was again defined by Hoff. So first colligative property was relative lowering in vapor pressure. Relative lowering in vapor pressure. What was the formula? P naught solvent minus P solvent by P naught solvent is equal to mole fraction of solute. This we have proved already. Okay, second colligative property was elevation in boiling point will be equal to Kb into molality. Third colligative property was del Tf, depression in freezing point, is equal to Kf into molality. Fourth colligative property was osmotic pressure pi. Pi is equal to nRT by V. Pi V equal to nRT. So Hoff modifies the equation of colligative property. This we have got all the four colligative property. What was the colligative property? Those properties of the solution which depend upon the number of solute particles. So he modified that this will be equal to I into this. This equal to I into this, means all are multiplied by I. So this is the correct equation for the colligative property as predicted by Hoff. So what is the original formula? Del Tf equal to I into Kf into molality. Del Tf equal to I into Kf into molality. How can we determine I? So from starting that only we have discussed how to calculate I. Okay. So in our first, at the starting of the video, three questions we have taken. So in the first question I have taken KCl in water solution. In first question it was KCl in water. KCl in water. So you can back and see KCl in water. What is KCl? Ionic compound. If you keep in water, it will break and give K positive and Cl negative. What is the value of I for KCl? So I for KCl will be equal to, you remember this, this part. I for KCl will be how much? 112 by 1, that is 2. So we have calculated without I whatever value have come 1.86, but experimentally it was found that it is double of that. Why? Because I value is 2. So if you multiply it by 2 into this, then that will be double and that will be the correct one also. So what will be the value of I for KCl in water? The value of I will be 2. So 2 multiplied by 1.86 into molality 1. So that was the result. Now it is correct. Second question was glucose in water. So if you dissolve glucose in water, then what happens? Glucose neither dissociate nor associate. Again I repeat, glucose neither associate nor dissociate. So what will be the value of I for glucose? Say yes, 1. Very good. So glucose in water having the value of I is 1. So whatever second part answer was 1.86 and it is also experimentally matched, means that is right one. Okay. In the third one we have taken ethanoic acid in benzene. If you dissolve ethanoic acid in benzene, what will be the value of I? So ethanoic acid in benzene. What is ethanoic acid? It is CH3COOH. Now, so can we write ethanoic acid in this way? CH3C double bond O OH, CH3C double bond O OH. So you see, if we take 2 molecules of ethanoic acid, then there will be hydrogen bond. Hydrogen bond we know already in class 11 chemical bonding we have got. What is hydrogen bond? It is a weak bond formed by hydrogen atom with highly electronegative atom like fluorine, oxygen or nitrogen. Okay. So oxygen is highly electronegative, hydrogen is there, so there can be hydrogen bond. So if we say ethanoic acid we are taking in the solution of benzene, but ethanoic acid themselves dimerize to combine to make 1. 2 ethanoic acid molecule combine to give only 1, means here dimerization occur. So if dimerization occur, what is the value of I? I is half. Earlier we have discussed this part already. So if dimerization occur, the value of I is half. How dimerization occur? With the help of hydrogen bonding. With the help of hydrogen bonding. So what happened? The result, whatever we get 4.9. The experimentally result was there half. Experimentally it was found that the answer is half. So why half? Not half, 4.9 by 2. 4.9 by 2 means 2.45 was the answer. Why? Because the value of I was half. So half into 4.9, that is 2.45 was the correct answer. So now it is clear, the first 3 questions which I have given, why there was wrong and why middle one was right. Middle was right, other 2 was wrong. Why? Because in first one dissociation occurred, so colligative property will increase. In second one glucose was there, neither association nor dissociation occurred, so value will be same. In third one what happened? Ethanoic acid in benzene was there, so dimerization occur in case of acid, so colligative property delta F will be half because I value is half. So whatever be the result, there half, 4.9 by half, that is 2.45 was the correct answer. So I think it is clear. So from now we will use the formula as predicted by One-Hoff factor. So take some numericals and it will be more clear. Okay. So now one numerical we have taken from the exercise part, question number 2.41. Determine the osmotic pressure of a solution prepared by dissolving 25 mg of potassium sulfate in 2 liters of water at 25 degrees C. Assume that it is completely dissociated. Okay. Determine the osmotic pressure. So we have to find osmotic pressure is how much, and osmotic pressure is denoted by pi. This is osmotic pressure, pi will be how much? Can 25 mg of potassium sulfate, given mass of potassium sulfate is 25 mg. What is W? W is the given mass of this. Okay. Then 2 liters of water, volume is given 2 liters. At 25 degrees C, temperature is 25 degrees C, assuming that it is completely dissociated. So if it is completely dissociated, means we have to find the value of I, One-Hoff factor. In formula it will be used. So what is given? K2SO4. Okay. So for K2SO4, what will be the value of I if we break sulfate one time? How many times K? 2 times. 2 times of K, charge will be second one, positive plus. SO4 how many times? 1. 1 times of SO4, charge will be first one, 2 negative. So the value of I will be how much? Number of moles of particle after dissociation by before. After is 2 plus 1, 3. Before is 1. So the value of I will be 3. Okay. Again we want molecular mass. So molecular mass of K2SO4 will be how much? That is molecular mass of K2SO4. Potassium 39, 2 times is there, plus sulfur 32 plus oxygen 16, 4 times is there. 39 into 2 plus 32, 16 into 4. 39 into 2, 78, 32, 64. So 4 to 6, 10, 14, 1, 8, 11, 7, 11, 6, 7. This much gram per mole. Okay. So molar mass we have calculated. 8 to 10, 4, 14, 1, 6, 1, 7, 3, 10, 17. Okay. So what is the formula for osmotic pressure? Use it. The formula for osmotic pressure was molar mass. What is abnormal molar mass? So that I have written the definition. The molar mass which is either higher or lower than the expected value is called abnormal molar mass. So this definition you can write. Molar mass which is either lower or higher than the expected value. What is the formula of osmotic pressure? Pi V equal to nRT. Like PV equal to nRT, in place of P it is pi. And in formula I will be there. Why? Because association or dissociation is there. If any association or dissociation occur, so in formula I will be there. If no association, no dissociation occur, I will not be there, because the value of I is 1 if neither association or dissociation occur. Okay. Pi we have to calculate. V it is given. I it is found 3. N R. What is N? Given mass by molar mass. R. What is the value of R? 0.0821 liter atmosphere per Kelvin per mole. 0.0821 liter atmosphere per Kelvin per mole. Okay. temperature, convert it into Kelvin, because in Kelvin we use generally 25 plus 298. How much it will be? This equal to 25 plus 273, 538 and 7292, 298 Kelvin. 273 plus 25, 298. Volume is okay, liter form, liter. Given mass. Now, it is in milligram, but mass we are calculating in gram. So, milligram can be converted to gram by dividing 1000, because molar mass in gram per mole, so gram should be there. Give the all values. What will be pi? Pi is equal to I n. What is n? Given mass by given mass of K2SO4 by molar mass of K2SO4. Given mass by molar mass. Okay. So this implies pi will be equal to pi is equal to I n. N is given mass of K2SO4 by molar mass of K2SO4. R T and V is divided this. Okay. Now give the values. I is how much? 3. Given mass 25 by 1000. R 0.0821. T 298 by molar mass 174. Volume 2 liter. Now simplify, whatever you will get, that will be our final answer. And what will be the unit of pressure? So in R, what is the unit of pressure? Atmosphere. So this much atmosphere will be the answer. So already we have discussed osmotic pressure, numerical already we have completed. The only one difference is there. Now if association or dissociation occur, then the value of I will be there, and in formula I will be used. Now how can we know that association or dissociation has done or not? So see, if ionic compound are there in water like KCl, magnesium chloride, ionic chloride we know compound formed by metals and non-metal. So if ionic compounds are there, so if you dissolve it in water, it will break into ions, then dissociation occurs. So for ionic compound, I will be greater than 1. And dimerization, trimerization occur, like benzoic acid in benzene. One example we have taken. So 2 benzoic acid join together to form a dimer. So remember it, any acid in benzene dimerize, as we have seen in the diagram by hydrogen bonding. So let us take one last numerical, then this lesson will be finished, solution and video will also be completed. So one last, one numerical more we will take. Okay. So numerical is calculate boiling point, calculate the boiling point of solution prepared by mixing 11.1 gram of calcium chloride in 250 gram water, 250 gram water. Okay, and it is given Kb for water is, what is Kb for water? 0.52 Kelvin kg per mole. Okay. Calculate boiling point of solution prepared by mixing 11.1 gram of calcium chloride in 250 gram of water. Kb for water it is given. So let's try. Now first you see what compound is given, calcium chloride in water. So see, calcium chloride is what? Calcium is metal, chlorine is non-metal. So metal and non-metal, so the compound between metal and non-metal is ionic compound. So ionic bond will be there and ionic compound will break into ions. So first we have to find the value of I. In formula I will be there. Okay. So first find I. So calcium chloride break. So calcium 1 time, charge will be 2 positive, plus chlorine 2 times, charge will be -1. What will be the value of phi? Particle after dissociation, 2 plus 1 3, before is 1. Value of phi is 3. Again what is given? Given mass of calcium chloride is, given mass of calcium chloride 11.1 gram. Find molar mass of calcium chloride. Molecular mass will be calcium 40, chlorine 35.5, 2 times is there, 40 plus 71, 35 to just 70.51, that is 111 gram per mole. Okay. Another 250 gram of water, given mass of water is 250 gram. Okay. Convert it into kg. Why? Because mass of solvent is taken in kg in the formula of molality. This you know already because you have done elevation in boiling point, numerical also you have completed. So this part you know already. Kb is given. Okay, use the formula. First we will find del Tb, and from del Tb we will find boiling point of solution. Why? Because del Tb is what? Boiling point of solution minus boiling point of pure solvent. Okay. So first find del Tb. What is the formula? Del Tb was Kb into molality. Kb into molality. So in formula I will be there if association or dissociation occur. What is I? I is 3. What is Kb? Kb is 0.52. What is molality? Molality is formula given mass by molecular mass into mass of solvent in kg. Number of moles of solute, number of moles given mass by molar mass. Molality, number of moles of solute. What is solute? Calcium chloride. How can we find moles? Given mass by molar mass into mass of solvent in kg. Okay. Give the values. 3 into 0.52 into given mass of calcium chloride 11.1, molar mass is 111, mass of water in kg 1/4. So we have converted it into kg. Okay, it was in gram, we have converted to kg. Now simplify. So this will cut by 10, 4 upper, so 4. Now so this cancel this 10, so this 2 2s are 4, 2 5s are 10. So this 2 will go upside. Okay, so 2 into 3 6, 6 2s are 12, 6 5s are 30, 31. So 3.12 divided by 5 is there. Okay, now simplify it. 5 6 ja 30, 5 6 are 30, 1 2 5, 2s are 10, 2 0 5 4s are 20. 5 6 are 30, 1 2 5 2s are 10, 2 0 5 4s are 20. So this much Kelvin is the del Tb. But what we have to find? We have to find boiling point of solution. So in the definition of del Tb, boiling point of solution is there. Now use that one. So I am rubbing it. Pause the video and write it. Okay. So use the formula. Del Tb is what? Boiling point of solution minus boiling point of pure solvent. Boiling point of pure solvent. What is del Tb? 0.624 del Tb given, and boiling point of solution we have to find And boiling point of water, pure solvent, pure water. What is the value of pure water? That is 100 degrees C, that is 373 Kelvin. This is for pure is 100 degrees Celsius. If you convert in Kelvin, then this will be there. From here you can find boiling point of solution. This is equal to minus come to this side plus, so 373.624 Kelvin. So this is our final answer. So with this, the lesson solution is finished, and this was the last video, one-third factor and lesson, lecture number 12.